Hey folks, since in our previous session what we have done is we have performed something known as word-to-vec representation with respect to some of the text that we have. Along with that, we will also touch upon the pseudocode with respect to our nothing but our TF-IDF weighted word-to-vec. So in this session, let's try to implement something known as TF-IDF weighted word-to-vec representation of our data. Let's try to implement that. Again, for those of you who do not know what exactly this stands for, kindly check out my previous video where I have explained all the pseudocode, how to implement it completely from scratch. So I will say, if I will say, let's say data of question of, let's say, zero syntax. So this is the data that we have. Now similarly, if I will say data of question, the moment I will execute, this is what I will end up getting. Now what I will do is I will say, hey, can I convert this into a list data structure so that I can iterate on top of the list that you have. The moment I will execute, this is the list data structure that we have. So first and foremost, I will say, hey, can I iterate as, let's say, for question 1 in the list that you have. Now, whatever question 1 we have to just pass this inside my NLP so that we will end up getting some document. I will say it is question 1, and whatever we will get, let's try to store, let's say in document 1. Cool. Now, whatever document you have, with respect to that document, particular document, if you need word-to-vec representation, you can think of iterating on top of that document. So I will say, whatever document I have, I will say for word in document, whatever document we have, now we will end up getting a word from this document. Now, considering this word, if I will say word dot vector, it will typically return a vector representation of the word that we have. So I will say, hey, let me store this in, let's say, vector 1. Now the moment I will call this vector attribute, it will return some vector representation of the data. Now let's say with respect to word, let's say what, we will end up getting some vector representation. Now we need to multiply it by TF-IDF score of what, let's say 0.6. But first and foremost, we need this value 0.6. What I will do is I will say, hey, I have a dictionary which is all about word to TF-IDF. The moment I will pass my key as my what over there, we will end up getting our TF-IDF score of that particular value. So I will say, hey, whatever matrix I will get, just multiply it by TF-IDF score. Let's try to do it. So I will say, first and foremost, I have to use this word to TF-IDF. Now, whatever word we have, I will say str of what. Now it will return basically a TF-IDF score. So I can think of something known as, I can think of storing this in, let's say, IDF in a variable, let's say TF underscore IDF, or let's say only IDF. But what if it will return some error? So in such case, I can say, hey, can I implement something known as exception handling? What I have implemented, I think, in the second session of this module, using all these lines of code. Now similar stuff over here. Now whatever try over here, it means the moment if there is some exception in this line of code, or if there is any error in this line of code, we can say as except if there is any error, just put a IDF value as 0. Cool. Now whatever vector 1 we have, I will say just multiply it by TF-IDF value, or let's say IDF value, because here we have stored that particular value in my IDF variable. Cool. But here comes an interesting thing. Let's say I have 2 matrices, let's say 3 matrices, and let's say sentence is all about, let's say, I love AI. But one of the main challenges, what can be the size of the final matrix that we have, which is nothing but, let's say a mean matrix, or let's say mean vector matrix. What can be the size of this? So I will say its size is all about m cross n, where m is all about nothing but the total size of the document that we have. I will say m is all about, let's say, 3. Similarly, n is all about the vector representation, or the initial vector representation of this word. Again, you can just get its initial vector representation by just calling a vector property on top of the text that we have. So I will say whatever vector representation I will get, hey, can I call a len on top of that so that we will end up getting our size n. Let's say size is, let's say 200. So it means our mean vector matrix dimension is all about 3 cross 200. This is how you can think of achieving that. It means first and foremost, what I will do is I will say, hey, can I create a matrix of, let's say, 3 cross 200. If I have such text where I have all the zeros, now whatever values I will get, I will say, hey, whatever values I will get, just store a new value in this matrix, in this zero matrix that we have, or a null matrix that we have. So I will say it is all about nothing but the moment I say, let's say doc of, let me show you one more thing. So if I will call NLP on top of our question 1, the moment I will execute, this is what I will end up getting. Now if I will say let's store this in, let's say doc2. Cool. Let me execute. Let me print doc2. This is our doc2. Now if I will say, hey, can I access our, let's say, zeros index data? This is what. On top of this, if I will call, let's say, vector representation of this, this is what I will end up getting. Now just to compute its length, just to compute the length of the first word, the moment I will execute, you will see you will end up getting a dimensions, or let's say n value is 96. Cool. And if I will say len of doc2, this is your m value. Now what I will do is, if I will say numpy dot zeros of 14 comma, let's say 96. Cool. First and foremost, I have to define my numpy. So I will say numpy as np. Cool. Let me execute. Oh, my bad. It says, hey, it cannot interpret 96 as a data type. Let's check out its entire documentation. It says, hey, you have to mention some shape. Cool. So again, shape is all about a tuple of ints. You have to mention in the form of tuple. So I can say it's all about nothing but 14 comma 96. Cool. Let me execute. Now this is what you will end up getting. This is the null matrix having a dimension of 14 cross 96. Now this is what you really need with respect to all the data that you have. But here your m and n can vary depending upon the question that you have. So I will say here your zeros must be nothing but length of whatever document 1 you have. This is your m. Then I will say document 1 of 0. You have to access your first word dot vector. Cool. Then whatever it is, you have to just compute its length. Cool. And you have to just mention all the stuff. Let's try to store this in, let's say, mean underscore vector of 1. Cool. Now whatever mean vector you will get, which is all about a null matrix, you have to update your mean vector. So I can say mean vector is nothing but mean vector plus whatever the vector representation along with the ID of a score with respect to the particular word that you have. Now the moment I have all that stuff, first and foremost, you need to provide the right indentation. So I will say it is all about this. Cool. Now you have all that stuff. Now in the end, you have to compute the mean along the column in your mean vector. So I will say it is all about nothing but mean vector dot mean, and here I have to mention x is equals to 0 because I have to compute mean along the column. Cool. Now the moment I say this, let's try to store the mean somewhere else. So I will say, let's say it is all about mean. Now you have to store this mean somewhere else. So first and foremost, I have to define some list. So I will say, let's say vectors 1, just to store all the mean with respect to each of the question that you have. So I will say vectors 1 dot append. Now what we have to append is, we have to append the mean. So I will say, hey, can I, or let's try to make it as, let's say, mean underscore vector, just to make things more clear. So I will say it is mean underscore vector. Cool. Again, if you want to showcase the progress bar or the progress meter of this entire lines of code, you can think of using one of the extremely popular module of Python, often known as TQDM. So first and foremost, you have to import that TQDM. So I will say from this TQDM, I have to import something very fancy, which is all about TQDM. This is exactly that module. Again, for those of you who haven't installed it earlier, you can install it using !pip install TQDM in your notebook. Sounds good. Let's execute this line of code and let's call this TQDM on top of the list that you have, so that you will end up getting a progress bar, how exactly the code is progressing, or you will end up getting a progress meter. Cool. So let's execute this line of code. Again, first check whether there is some error or not. It says wax1 is not defined. Oh, my bad. It is wax. Cool. Let me execute this line of code. Now you will end up getting such amazing output. Look at this. Look at the progress bar that you will end up getting. It says, hey, this is the count that you will end up getting. Again, this progress bar may vary depending upon the specification that you have. Now it says there are total 10% iterations that successfully executed, and we have 10k data points. Out of 10k data points, probably close to 1200 questions or probably close to 1200 data points we have computed successfully. That's what it says, and it says 20 iteration per second. This is typically the speed that you have. This is what it is doing. Again, for those of you who have any doubt with respect to the code that we have, please feel free to ask with us in the Q&A of the course. Again, as we have 10k data points, these lines of code probably take hardly 2 to 3 minutes depending upon the specifications. Again, for those of you who do not have good specification, even you can pick, let's say 200 or let's say 2000 data points. I think 2000 data points are enough just to judge how well something is performing. So that's all about the session. In the upcoming session, what we'll do is we will try to prepare our entire data. Along with that, we will also try to touch upon how to do it or how to perform some multiple operations so that we will end up getting our final data, so that on top of that we are able to call our machine learning algorithm. That is exactly our main goal in the upcoming session. So that's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.